cardstock paper. This is copy paper. This is construction paper. The copy paper crashed on its way, and the construction paper crashed on its way also, and the cardstock paper went further.
Hi, my name is RGCCISD, and this is my science experiment. Which type of soda tastes better? Can people actually taste the difference? We have name brand versus generic brand. For the name brand, I chose Coca-Cola. And for the generic brand, I chose Sans Cola. I think people will be able to taste the difference between the name brand and the generic brand soda. Person 1 be able to taste the difference. He said Coca-Cola has more gas. Person 2, he also taste the difference. He said Sans Cola is sweeter than Coca-Cola. Person 3, he can also taste the difference. He said Sans Cola has a flatter taste. 3 people were blindfolded and tasted both sodas, and all 3 were able to taste the difference. In conclusion, my hypothesis was correct. Thank you.
My name is Jaden Davila. For my experiment, I'm going to find out which gum flavor lasts longest. My cousins will help me out. My name is Shayel, and I'm going to be trying Starburst gum.
My name is Shalomi, and I'm going to be trying Bubble Yum.
I am going to be trying Bubble.
3.
Each one of us will have a timer to find out which flavor lasts longer. 1. Ready? 1, 2, 3. Oh, we're already done. We already have the results and the timer. Thank you for watching. Bye and stay safe. Bye. Hello everyone. My name is Omar Trevino. My project's name is Which Food Does My Pet Like Best? So first I got 2 bowls. One has the family leftovers.
Go.
And on this side, I have my pet's favorite dog food. First, Axel is gonna try the family leftovers. Let's see if he likes it. As you can see, he's eating the family leftovers.
He's just licking it. Not really eating it. So as you can see, Axel only ate about 10% of the family leftovers. So now it's time for his favorite dog food. Axel, come on. Come and eat. Wow, he's really digging into it. I think he really likes it. Excuse him, he just burped. As you can see, after a few seconds, almost all his dog food is gone. Wow, Axel finished all his dog food. Axel ate 90% of his favorite dog. My topic was what chocolate would melt the fastest. I chose Hershey's, cookies and cream, and Milky Way. After an hour of leaving the chocolates under the light, we saw that the Hershey's was much softer than the Milky Way. Chocolates will melt because of the heat. This is how they ended.
Hello, my name is Liam Sedna and I'm a third grader at General Sciences. My project is Laundry Lab. I had a question about which detergent worked better. I bought 3 different brands. They were Tide, Gain, and Extra. My hypothesis was that Tide detergent worked better since it cost more money. To get things ready, I stained 3 pieces of white cloth with grass, ketchup, chocolate candy, and oil, and I let them sit overnight. Then I added the same amount of detergent to 3 different bowls and added the same amount of water to each one. I soaked them for the same amount of time. I even stirred the water the same number of times as well. After being washed, I took them out to dry. I noticed that Extra left some visible stains on the cloth, while Tide and Gain left subtle stains after a closer look. I realized that Gain had left much lighter stains than Tide. In conclusion, Gain was the better detergent. Tide was a close second, and Extra came in third.
Hello, my name is Kayla and I will be presenting my poster. And it's going to be the water cycle. Warmed on the ground, water changes from a liquid to a gas. Water vapor cools as it neeses and it changes back into a liquid. Water falls back to the earth in form of hail as Rain, sleet, hail, or snow. Water is sorted on Earth as streams, rivers, lakes, oceans, and as groundwaters. And as you can see, there's groundwaters, and it just goes like that. And I'm out.
Hi, my name is Mariah Garcia, and I'm in second grade with Miss Science. There are currently 1,500 active volcanoes. Volcanoes erupt when magma rises to the surface. Volcanoes are dangerous and destructive. Today I will do a science experiment mixing baking soda and vinegar to simulate the eruption. Safety first. Now let's start. So I'm gonna get my vinegar beaker and pour it inside. But I have to take this away from the volcano so it wouldn't get wet. So now I am going to pour the vinegar inside the volcano. Here we go. In real life, it would go higher and higher, but since we have less vinegar than in real life, it would do slower, and real volcanoes will pretty much not do the same thing. They will actually flood the whole entire place. Let's see what happens if we add more vinegar to the volcano. Oh! That's a little bit like, that's almost like real life, but they would go into the air. Here's a fraction about the volcano. Here's the magma. And here is everything about the volcano you have to see. This is the eruption cloud. That's all the fog. The eruption is right there. This is how the real volcano looks like, and this is how they look like in real life. This is the Augustine volcano in Alaska, and the other one is lava shooting out of a volcano. There are many different things that are volcanoes. Some volcanoes live in snow. Some volcanoes live in dark places. Some of them live in light places. There are many opposites about different volcanoes. Bye, see you next time. Thank you for watching. I hope you like my video. Bye.
Hello, my name is Audrey Pratt. I am a 4th grader at General Ricardo Sanchez Elementary School. I have done my Science Expo experiment on the topic of planting. The title of my experiment is The Science Behind Planting. It is an experiment in which I ask the question, will a plant seed grow better in topsoil or rocky soil or in potting soil? When I started this experiment, I believed that my bean seeds would grow best in a mix of garden soil and potting soil. The experiment began when I gathered the materials necessary to complete my project. I got 5 pots together, 3 different types of soils, which included topsoil from my dad's garden, rocky soil or caliche, and potting soil. The rest of the materials included bean seeds and a watering can. I decided to plant 3 seeds in each pot, and I had placed 3 different soils in 3 different pots. The first pot was simply topsoil from my garden. The second was potting soil, and the third was rocky soil. I also decided to mix the garden soil with potting soil to have a 1-to-1 ratio, and I mixed the potting soil with the rocky soil to have a total of 5 pots altogether. I planted 15 seeds, 3 per pot, and watered them. I did not see growth until 7 days after planting the seeds. They sprouted first in the potting soil and in the garden soil. The other pots did not grow any of the seeds, which was surprising. I figured that I would see growth in at least 3 or maybe 4 pots, but there was only growth in 2 of the pots. As you can see in the graph I provided, there was growth over several days, and then the plant seemed to stop growing. The plant started to showing of growth because there were some leaves growing larger on the plant, and a small flower began to form towards the end of the project. Overall, the project provided me with a better understanding of the types of soil and how well they will grow seeds. The greatest growth I saw was in the potting soil. The garden soil did grow, but I noticed that the soil would get hard and the bean sprouts needed to have a little less water to grow than the potting soil bean plant. The potting soil always stayed soft and moist, but the garden soil and the rocky soil got very hard on the surface. The final days of my experiment showed me that the plants grew best in the potting soil. I believe that this is the case because that soil is specifically designed to grow plants. Sometimes garden soil and rocky soils will grow plants, and I did see growth in the garden soil. As a matter of fact, 3 beans sprouted, and only one of the 3 potting soils. The soil that yielded the best result was the potting soil because that plant that sprouted survived. The 3 that were planted in the garden soil sprouted through the tough soil, but also did not leave leaves immediately like the other softer potting soil plant did. In conclusion, the potting soil did give me the best results. This was not my original thought, but it turned out to be the best conditions overall. I have to say that this project helped me to understand the process of growing plants much better and has gotten me interested in what other possibilities there are in growing my own garden. Thank you.
Hello, my name is Jaden and I'm a 4th grader in Miss Hinojosa's class at General Ricardo Sanchez Elementary. Today I will explain to you how clouds are formed. You will need warm water with a jar with a lid, ice cubes, and hairspray. In order for clouds to form, you need warm, moist air. Next, you need a cooling process, which are the ice cubes. Lastly, you need something to start the clouds. For example, a dust particle. In this experiment, I'm using hairspray. By pouring warm water into a jar and trapping it, you created the first step, which is warm, moist air. This warm air rises and meets with the cool air at the top of the jar, which is made by the ice cubes. The hairspray presides the cloud condensation. When you remove the lid, the cloud is released. Thank you. Hope you enjoy.
Space, the last frontier. These are the exploration of Ringgold Elementary students, their mission to explore the 8 planets and boldly go where no student has gone before.
Did you know the solar system is made up of stars? book, and each planet has its own story.
Really?
Yes, do you want to explore the solar system together?
Let's take chances, make mistakes, and get messy.
Now sit back, relax, and enjoy our short production of Ringgold Elementary. Explore the solar system.
The sun is a big ball of gas. Like a ballerina? Yes, something like a ballerina. Did you know that running lives can spin inside the sun? Wow, that's a lot of Earth. It provides us with light and without the sun, we won't be able to wake up and need to survive. Wow, that sounds a pretty part of the solar system.
Thank you, Asali and Gabby. The sun really looks to be the center of attention.
Can we continue exploring the solar system?
Sure, what's up next?
Mercury and Venus. Let's see what Angela knows about these two planets. The first four planets are the first footprints, which means they're made of rock. They're also known as the inner planets. Mercury is the third planet from the sun. Mercury it is made for it to revolve around the sun. One day, Mercury left 126 Earth days. It is named after the Greek god Hermes. It does not have any rings or rings, and is the smallest of all the planets. Venus is the second brightest natural object in massive after Moon. It is hotter than Mercury, despite being further away from the sun. It takes 243 days for it to rotate or spin on its axis, and 225 days for it to revolve around the sun.
Wow, did you know Venus is also known as Earth's twin?
Yes, I did. The reason it is known as Earth's twin is because it is the same size as Earth. Should we continue exploring the last two inner planets?
Sure, let's continue with our planet Earth. Earth is the only planet that has life. It is made up of 75% water and only 1% is drinkable water.
We should conserve water and help solve a solution to keep this planet clean.
Did you know they once believed the Earth was the center of the solar system? They believed the planets and stars rotated around Earth.
Wow, that is unbelievable.
The last inner planet is Mars. Mars is the fourth planet from the Sun and the second smallest planet in the solar system. It is known as the red planet because it is covered in red dirt. Mars is home to the largest mountains, dust storms in the solar system.
I know Mars is the fourth planet because it has 4 letters.
Let's continue exploring the solar system with the outer planet. They are gas giants.
Hi, Athena. Tell us about Jupiter and Saturn. Jupiter is the 5th planet from the Sun and the largest in the solar system. Jupiter has the shortest phase of all the planets, and it takes 11.8 Earth years to revolve around the Sun. The Great Red Spot is a huge star that continues for at least 350 years. It is so large it can be 3 Earths inside. Amazing! Jupiter has a lot going on, including 10 rings and 79 moons. Do you know you cannot stand on Saturn because it is mainly made of gas? It would also float on water.
Does it have any moons?
Yes, Saturn has 82 moons. Some scientists believe it rains down on Jupiter and Saturn because they have calculated lightning storms, carbon which falls into the heart of the sky. That is Cardinal's best friend.
Thanks, Isaiah, for the information of Jupiter and Saturn.
No problem. I love learning about planets and stars. Come on, Julia. We have 2 planets left and I know everything about them.
Okay, good
planet is next. Uranus is the seventh planet from the sun. It was discovered in 1781. It takes 84 Earth years to evolve from Earth to take one trip around the sun. Uranus hits the coldest center of any planet. It is known as the sideways planet because it rotates on its side. It is an ice giant and nearly 4 times larger than Earth.
Fun fact, Uranus is the first planet to be discovered with a telescope.
Impressive, Julian. That's a cool fact. Finally, the last planet in our solar system is Neptune. It is the farthest known planet from the sun. Neptune is the smallest of the gas giants. A year in Neptune lasts 165 Earth years.
That's a wrap. It's been great exploring the solar system with you, Jennifer. Maybe next time we can explore the 23 flavors of basket rubber.
Especially how Rocky Road is made.
My project is called Battery Life. I will be using 2 different brands of batteries, Duracell and Dorsey, to determine which battery has a longer life. I will do this by leaving both flashlights on with the 2 different batteries in my room. The materials I will be using: 2 flashlights, 2 Duracell batteries, 2 Dorsey batteries. Hypothesis: Duracell will last longer because it is a well-known brand. Day 1, I turned on both the flashlights and left them in my room. The blue flashlight contains the Duracell batteries. The red flashlight contains the Duracell batteries. The Dorsey batteries. Day 3, the flashlight with the Dorsey batteries got slightly dimmer. Duracell brand continued the same. Day 6, the flashlight with the Dorsey batteries started flickering. Duracell batteries continued the same. The flashlight with Dorsey batteries in it completely turned off. Duracell got dimmer. Day 12. Dorsey batteries continued the Dorsey batteries gone out while Dorsey stayed on. The results are that Dorsey batteries gave out on the 9th day, while Duracell lasted the 12 days in this experiment.
These are the results. White vinegar took less time, 24 hours, but made the egg less bouncier. Apple cider vinegar took longer, 48 hours, but made the egg much more bouncier. Pickle vinegar had no effect on the egg after 48 hours. It still had a hard shell. Conclusion. White vinegar, which has more acidity, 9%, did in fact make the egg bouncy in less time, 24 hours, like I stated in my hypothesis. Apple cider vinegar made the egg much bouncier, but it took much more time, 48 hours. Pickle vinegar had no effect on the egg after 48 hours.
Hi, my name is Giselle Martinez. Today I will be presenting my experiment, the floating egg. When I heard that adding salt to water could make an egg float, I wanted to know exactly how much salt needed to be added to make the egg float. My hypothesis was that if I added 4 teaspoons to 10 ounces of water, the egg would float. In order to test my experiment, I used the following materials: 5 clear cups, water, salt, teaspoons, 5 raw eggs. These are the steps I followed when making my experiment. I gathered all the material, then I placed 10 ounces of water into each clear cup. In one of the cups, I added 3 teaspoons of salt and stirred to dissolve the salt. I added 4 teaspoons of salt in another cup and 5 and 6 teaspoons in another cup. I made sure to stir to dissolve the salt in all cups. Place 1 raw egg into each cup filled with water and salt. These are my observations. 0 teaspoons of salt, egg sat at the bottom of the cup. 3 teaspoons of salt, egg was still at the bottom of the cup. 4 teaspoons of salt, the egg barely floated in the cups that I added. 5 and 6 teaspoons, the egg floated. So my results were that the egg floated in the cup of water that had 5 and 6 tablespoons of salt. In conclusion, my hypothesis was not correct. The egg did not float on water with 4 teaspoons of salt. I needed more. It actually floated on water with 5 to 6 teaspoons of salt. The egg floated because there was more salt added to the water. That means there was more mass added. Salty water is denser or heavier than plain water, so heavier in fact that it could support the weight of heavier objects like an egg. In this experiment, the independent variable was the amount of salt, and the dependent variables were the type of egg, water, clear cup.
Hello, my name is Miguel, and for my experiment name is Clean Copper. For my question for the experiment, it is which household product will remove oxidation from the pennies the best? My hypotheses.
I think that the lemon juice will clean pennies better than the other liquids, is my hypothesis. Materials: clean containers, pennies, water, and salt water. Vinegar, Coke, lemon juice, and a paper towel. For my producer, gather all 4 materials. Place 4 ounces of one liquid into 1 clear container. And after that, you want to repeat step 2 for the other 4 liquids. Place 1 penny in each container with different liquids. Leave the penny in the liquid for 10 hours. After the 10 hours, remove the penny from the liquid and dry it out with a paper towel. Make observations. For my pictures here, for water, I didn't clean it. It didn't have no effect on the penny. It stayed the same. For salt water, it didn't clean it. It cleaned it a little, but not that much. For lemon juice, it cleaned it the most. It had the most effect on all the pennies. For vinegar, it just took away the color. So you can see here, this one's darker and this one's lighter, but it's not the same as the other. It took away the color like fake. And for Coke, it was a little dark, but then the Coke made it a lot more darker. For my results, were that the best liquid to clean pennies is lemon juice.
My conclusion, my hypothesis was correct. Lemon juice is the liquid that cleans pennies the best. Thank you.
Hello, my name is Brian Sarasua and I am in 5th grade. This is my project and my project's title is Drink Dispenser. The question of this project is, how does a drink dispenser work? As my hypothesis, when the balloon's air is released, it will become trapped, making air pressure. The water will be pushed through the straw and come out, which it is when the water pumps out. In this project, you will need a balloon, a peg, a plastic bottle, a plasticine or a putty, a plastic straw, water, and a small container. In the procedure, step 1 is make a small hole about halfway or bit up of the bottle, not too low. Step 2, fill the bottle about 300 millimeters full with water. Blow up a balloon, twist and seal the neck with a peg. Carefully place the end of the balloons on bottle, neck, and put a container under the straw. Step 3, when you're ready, remove the peg and the water as the water shoots out of the straw into your container. Before we go with data and conclusion, photo number 1, this is when I still do not put anything water, it's just a cup, and this is when it has water. Right here it has a demonstration that the water is getting pumped out. And here is, it cannot be that visible, but it is when the water is in the cup, in the container. Now going to data, now with these photos that have been seen, the data is, it works by air release that presses the water, which is why when water comes out of the straw. Which is my conclusion, I was right. This works because air presses down equally on the water in the bottle and in the straw when there is no balloon present, but when the peg is removed, air from the balloon increases the air pressure in the bottle, pushing down on the water, forcing it through the straw. Now I'm going to show you a demonstration of my project. As you may notice, I do not have 2 of the materials. Project. Thank you. Bye.
Ladies and gentlemen, I'll be telling you a project of cookie chemistry. 1. The question: what happens if you leave out baking soda in chocolate chip cookies? Hi, Papa. I think chocolate chip cookies without baking soda will be hard, flat, and small. Materials: cookie sheet, measuring cups, measuring spoons, bowl, oven, flour, butter, sugar, egg, chocolate chips, baking soda, vanilla extract. Procedures: turn on the oven. Mix all the ingredients. Place cookie dough on heat. Bake for 15 minutes. Cool the cookie. Compare the chocolate chip cookies. Results. The cookies without baking soda were smaller, harder, and crunchier. The chocolate chips cookies with baking soda were fluffier, softer, and bigger. Conclusion. My hypothesis was correct. The chocolate chip cookies without baking soda were flat, small, and hard.
Hi, my name is Leticia Garza. I'm a second grader in AC2 Elementary. My teacher is Miss Roxanne Benitez. And my title for this project is called Fuzzy Fun. And my science project is putting baking soda in household liquids. I decided this project because baking soda experiments or activities are a great, safe, and easy way to introduce the concept of the chemical reaction to children. These are the materials we're going to be needing: baking soda, vinegar, Windex, Coke, disinfectant water, spoons, and containers. You don't have to use the same household liquids as me, but you will be needing baking soda, spoons, and containers. Let's move on to the explaining. Disinfectant water did not have that much acid or chemical reaction, and it was the same as the Windex. The Windex also did not have that much acid and chemical reaction. But the Coke did have a lot of chemical reaction, a medium size of chemical reaction. And acid had a medium amount too, as the same as a chemical reaction. But the vinegar was not the same as this one. This one had much more acid and chemical reaction. In that case, I think the vinegar would be the most fizzed out of all of them. Let's move on to the question. What happens when you put baking soda in Coca-Cola? Baking soda and Coke reacts because Coke contains an acid and baking soda can behave as a base. In this case, now we're going to go to vinegar and baking soda. The reaction is known as acid-base reaction. Baking soda is the base as the vinegar is an acid. Vinegar isn't just an acid. It is an acid in water, which is important. The carbon dioxide is a gas which is released during the reaction, which gives it bubbling effects. Why does baking soda not react with some liquids? Baking soda is a chemical compound that adds volume to baking soda goods. However, without the acid, that baking soda will never be active and your creation will be disappointing. Now we're going to move on to the results. The results of my project was that baking soda only was active with the Coke and the vinegar as a result of the acid-base reaction. With the Windex and disinfectant, it didn't work because they were not acids. It would change the Windex and the disinfectant and put something like lemon juice or other acids that will work like it was with the vinegar and the Coke. So I would think of my science project as easy, safe for kids. If they're bored or anything, I would recommend this project for them. Only if you're bored and have a parent to help you. So that was my science project. Bye!
Hello everyone, my name is Jacob Pinoza. My experiment is germs on laptops. Question: whose laptop has the most germs? Is it a kid's laptop? Is it a teen's? Or an adult's laptop? For kids, I'm going to be using mine. For teen, my sister, and for adult, my dad's. I decided to do this experiment because now most of us are learning from home and a lot of adults are teleworking. Because of this, people are using laptops more. I think it is important to know how many germs are on our laptops. Hypothesis. My guess in this experiment is that the kid, my laptop, will be the one with the most germs. Kids have always been known for not washing their hands. Materials. Lab coat, goggles, gloves, laptops, one for each age group, agar plates, distilled water, cotton swabs, marker, and cardboard box. And this is a picture of all the materials gathered together. Procedure details. I have swapped and tested 3 different laptops from 3 different age groups, and this is how I did that. First, put lab coat, goggles, and gloves, and gather all the materials. Label 2 agar plates for each age group. Damp cotton swab in distilled water to gather more germs. Remember to use a new cotton swab for each laptop and trial. Swab the laptops thoroughly to collect germs, and that is me doing that. With the damped cotton swab, spread the invisible germs to the agar plates like drawing lines, and that is me doing that step. Repeat these steps for a second trial. When finished, place closed agar plates in a cardboard box in a warm environment for about 5 days to get the results. The results of my experiment show that the agar place with the most germs was the kid, my laptop. As you could see from 2 trials, the agar plate with the most germs is from my laptop. However, my sister's and my dad's are just slightly different. Conclusion. My hypothesis was correct. The results were as expected. The laptop with the most germs was mine, the kids' age group. But to my surprise, the other 2 age groups showed slightly less germs. Now we know to keep our laptops clean. Thank you.
Hello everyone, my name is Siana Mendoza and I'm a 5th grade student at AC2E Elementary. The project that sparked my interest was the Big Bubble Fight. Well, it's not really all about fighting, but I guess you could call it a competition. And let me show you something really cool before I explain something really interesting. Watch this. I mean, the thing that sparked my interest in this project was that so many different shapes, so many different sizes, so many different colors, textures, and just all of that just got together in my mind and I was like, this is the project I was gonna do. The hypothesis for my project was that Hubba Bubble will blow the biggest bubble due to the fact that it has the most sugar content out of all of the bubble gums. The questions were, what bubble is bigger? What is the elasticity of the gum? What is the sugar alcohol? What is the mass? Is this gum toxic to dogs? My materials were very simple to find. Wrigley's Juicy Fruit, Trident Watermelon, Wrigley's Orbit Peppermint Gum, Mentos Spearmint Sugar-Free Gum, Hubba Bubba, a camera,
a notebook, a ruler or a measuring tape, a pencil or a pen, and of course, your marvelous test subject. My procedures were also very simple. Gather up all your materials, open your gums individually, and put them into an organized pattern just like this. Your test subject will chew the gum 75 times. Write the data as the brand of the gum, then make the length. Make a chart, which is very optional. I don't know if you can see here. At the very end, you will get a close-up of my project board. The Mentos Spearmint Sugar-Free Gum was 1 piece per chew due to the sizing. The width was 1 inch, the length was 1 inch, and the mass was 47.1 grams. The sugar alcohol was 1 gram. The elasticity, which is the stretch of the gum, how good it stretched. Yes, but it was on the very, very thin side of the gum. Like, made it very hard to chew, not chew, but blow the bubble. And is this gum toxic to dogs? Yes, do not recommend giving it to your animal or dog. Hubba Bubba is 5.5 inches in 1 strip that we use. The width was 2 inches and so was the length. The mass was also 47.1 inches. The sugar was 5 grams and the elasticity of the gum, which is also the stretch of the gum. And yes, I really like the elasticity because it made it really easy for me to blow the bubble. And this gum is also very toxic to dogs. Wrigley's Orbit Peppermint Gum was 2 pieces per chew. The width was 1.5 inches and the length was 1 inch. The sugar alcohol was 2 grams and the mass was 47.1 grams. The elasticity of the gum, which is the stretch, it didn't work out. It was too clumpy and too thick. So no, it wasn't. If you don't want to blow bubbles, this is the gum for you. But if you want to blow bubbles, don't recommend it. The Trident Watermelon was 2 pieces per chew. The width was 1 inch and 1/4 inches. The length was 1.5 inches. The mass was 47.1 grams. And the sugar alcohol was 1 gram. The elasticity, which is also the stretch of the gum. Yes, but it was also very thin like the Mentos. And this gum is also very, very toxic to dogs. Wrigley's Juicy Fruit was 1 square per piece. Because I mean, like, look at this thing. It's giant. Imagine having 2 of these in your mouth. Oh my goodness, you would explode. The width was 3.5 inches and the length was 3 inches. The mass was 47.1 inches and the sugar was just 2 grams. Is this gum toxic to dogs? Yes. And the elasticity was there. It was awesome. To conclude, my hypothesis was incorrect. Juicy Fruit had a staggering 3 inches width and length. Compared to the other gums, Juicy Fruit had better results. This is what my hypothesis was compared to my conclusion. This one had better results than this one. Now you will get my marvelous, marvelous close-up of my board. Thank you for listening to my project and I hope you enjoy your day.
Gianna. I am in 4th grade and I'm going to show you what I did for my science fair project. Does the type of liquid affect how quickly a candy cane will dissolve? These are the materials I used. I used 3 beakers, 16 fluid ounces of vinegar, and 16 fluid ounces of oil, and 16 fluid ounces of water, a measuring cup, and 3 mini candy canes, and the timer. Water is a pure substance and the candy cane is made up of sugar, and sugar is soluble in water. And the first thing we did was I gathered all my materials, and then I placed the liquids into the beakers, and then I dropped the candy canes into the beakers like this, and then I started a timer, and then I was seeing how it was dissolving quickly. I saw that the water took 32 minutes and 41 seconds to dissolve, and the vinegar took 37 minutes and 32 seconds to dissolve, and the oil never dissolved. It is still the same on how we put it in. As you can see, it's the same as a normal candy cane. I definitely had so much fun doing this experiment and was amazed that my hypothesis was correct. For a second, I was doubting my hypothesis because the vinegar container was also dissolving rapidly, but the container with the pure water did dissolve the fastest. After recording my data, I conclude that the types of liquids does affect how quickly a candy cane can be dissolved. This happens because sugar dissolves in water and candy canes are made of sugar. Bye!
My name is Cecilia Martinez, and today I'm going to be doing a science experiment called potato energy. For this experiment, I want to learn which type of potato is best to give us energy. The materials that we will be using is 3 different types of potatoes. I will be using the red potato, the sweet potato, and the russet potato. I will also be using these alligator clips. We will also need these copper coins. Don't forget the nails. And the last thing that we're going to be using is the voltmeter. For this experiment, we will also have to do 3 trials, but I'm only going to show you the first trial. The potato that I will be using is the red potato. The first step is to get one of the nails and stick it in. Then I will get a copper coin and stick it right next to it. Like that. Now, as you can see, I already turned on my voltmeter. But now we're going to test it out. You have to connect the voltmeter with the alligator clips in order for it to work. We have the reading for the red potato. It is 0.8. Now we are going to try with the russet potato. Now we're going to repeat the same procedure. For the russet potato, it is 0.9. Now we are going to do it with the last potato, which is the sweet potato. The reading for the sweet potato is
0.8. Now we need to do 2 more trials. My results. Based on my trials, the russet potato gets a little bit more voltage compared with the red and sweet potato. But for me, they almost produce the same energy. But the best to use is the russet. In conclusion, the potato produces energy when zinc and copper are stuck into the potato. And this is because the zinc and copper create a chemical reaction that can be read as voltage. I hope you enjoyed this fun experiment. Thanks!
Hello everybody, my name is Lynette and today I'm going to show you what I did for my science fair project. What I did was how does the type of container affect ice cream's melting time. Now before I start talking about my hypothesis, I'm going to show you what I used for my materials. The things that you're going to need are ice cream, glass, plastic and foam container, and a measuring cup. Now, on to my hypothesis. I predicted that the foam cup would melt very little because it's a very good insulator. Now, on to my procedure. 1. I gathered all of my materials and equipment needed for the experiment. 2. I put half a cup of ice cream into all 3 containers. 3. I waited 30 minutes and every single minute passed by, I kept on observing what would change. 4. After 30 minutes, I gathered a measuring cup and measured the liquid that would melt. 5. I recorded my results. Here was the start, 50 minutes, and then 30 minutes. You can clearly see once it's 30 minutes that mostly the glass cup melted the most. My results showed that the ice cream that melted the fastest was the glass cup that had 12 teaspoons of the liquid being melted, followed by the plastic that had 6 and foam that had 1. This experiment was a good way to test different containers and how the type of container will determine ice cream's melting time. This experiment was really fun because I got to use ice cream and that, that foam really melted a little bit. I was able to eat it. Thank you.
Hello, my name is Annette Science and I attend Roque Junior Elementary. I am in 5th grade and my science teacher is Miss Barba. Today I will be presenting the best way to clean a penny. Question: what liquids will clean a penny the best? Hypothesis: I believe salt water and vinegar will work the best to clean the penny. Materials: lemon juice, hot sauce, orange juice, paint thinner, Coke, and salt and vinegar, and the penny. Procedure: first I filled 6 plastic cups with 6 different liquids. The liquids I used were Coke, salt and vinegar, lemon juice, hot sauce, orange juice, and paint thinner. Second, I placed a United States penny into each plastic cup. Then I placed all of the cups into a tray and let them sit for 5 hours. Last, I removed the pennies out of each cup, wiped them with a cloth, and made observations. The penny and paint thinner remained unchanged. The penny and orange juice had a very slight change because the rim of the penny became slightly shinier. The penny and hot sauce had a minor change because it became shinier from the center of the penny as well as the rim. The penny and salt, water, and vinegar showed some change because the entire penny became shinier. The penny and lemon juice had a significant change because the entire penny became very shiny. The penny and Coke clearly showed the most significant change because it was the shiniest of all the pennies. Conclusion: After observing all of the pennies, I determined that the penny which well inside the Coke cup was the tiniest. It appears that the Coke reacted with the penny the most because of the high sugar content. Also, Coke has a high phosphoric acid content. Thank you.
Hello, my name is Edward Castro, and this is my science project. I attend Woodbury Elementary, and my 5th grade science teacher is Miss Betsy Barber. This is my try for a science project. Once it was finished, my science project was on electric currents. Electric currents is the flow of electrons. Voltage is the force that pushes the electrons through a circuit, like a pressure on a water pipe, and measuring voltage. The question is, what food has the most electricity to be used as a battery? The materials I use are 2 fruits such as orange, apples, lemons, and potato, multimeter, 2 red alligator clips, 2 black alligator clips, 4 copper electrodes, 4 zinc electrodes, 24 cardboard display board. My hypothesis is that orange has the most electricity because it has more sugar. The procedures for this assignments are: prepare the fruit for this project by squeezing them on all sides. Before using your hands, make sure to not squeeze too tightly and break the skin. Stick the zinc electrode all the way into the first fruit in the test. Attach a black alligator clip to the zinc electrode and place the copper electrode on the second fruit. Attach the potato clip to the copper electrode. Attach the opposite electrode to the both fruits to connect 2 alligator clips. Measure the current using the multimeter. Record your results. Remove the zinc and copper electrode from the fruits and wipe off of any juice. Repeat the same procedures using the different fruits. Record your results for each time. The results are follows. The apple, trial 1, 3.6 volts. Trial 2, 3.7 volts. The lemon, trial 1, 3.0 volts. Trial 2, 3.2 volts. The orange, trial 1, 3.1 volts. Trial 2, 3.0 volts. The potato, trial 1, 3.0 volts. Trial 2, 3.1 volts. My conclusion after 1 or 2 trials is that the apples has the most electricity to use as a battery.
The name of my project is Gummy Bears. I predicted that the soda will make the gummy bear grow the most because it has sugar. The stuff that I used was 3 gummy bears, 1 cup of water, 1 cup of salt water, 1 cup of soda, and a ruler. I poured 1 cup of liquid into each cup. I labeled the cups water, salt water, soda. I placed the gummy bears in the cups, and I observed the cups. Wait 4 hours and measure the gummy bears. After 4 hours, I took out the gummy bears and measured them again. The gummy bear that was in soda and water showed the most change in lengths. My hypothesis was correct. I predicted that the gummy bear placed in the soda would show the most change in measurement, and it did. The results of my experiment showed that the soda and water made the biggest difference. Both of them had the most changes in the conclusion. All of the gummy bears expanded in size due to osmosis. Gummy bears are made of water, sugar, and gelatin. Like a sponge, gummy bears absorb water. The gelatin in the gummy bears is like a cell membrane of cells. The gummy bears placed in water and soda grew the most because the water and soda move into the gelatin. This happens because there are more sugar molecules in the gummy bear than in the water and soda. The gummy bear placed in salt water did not change much in size. The water moved out of the gelatin because there are more salt molecules in salt water than in the gummy bear.
All right. Hey, Jocelyn.
Hey, miss.
So go ahead, tell us your name, what school you go to, and the title of your experiment. Oh, and what grade.
Okay. Well, my name is Jocelyn Chapa, and the grade level that I go to is 5th grade, and the school that I go to is Guru Elementary, and the title of my project is Chocolate Race.
All right, very good. So what gave you the idea of doing chocolate race? What was the purpose in the left side?
Well, because the purpose was I wonder what chocolate will melt the fastest, because it's basically I had to put 4 chocolates in every day, and I had to try to see which one could melt the fastest. So it's basically like a race, because whoever goes the fastest will wins it and then gets the number.
Mm-hmm.
So that's what gave me the idea to get the chocolate race.
Okay. All right. And you picked, 4 different candies. And which one did you think was going to melt the fastest?
Well, I thought the Hershey's was going to melt the fastest than the Reese's, because when I used to go to the store and I used to buy Hershey's, and like for a little bit I just got on the car and it was already water. So that's what I thought it was going to melt the fastest. So yeah.
Yeah. Okay. Very good. All right. Now, so with your experiment, what did you do? What was your procedure, like step by step? What did you have to do?
Well, the first step that I had to do was cut the candy in pieces. And once I did that, I actually got the mass of every single candy, and then I put them aside. Or after I masked them, and then I repeated it with all the other candies. And then now for number 5, I put, once you have all the candies, put them on the table. And then once I put that, turn on the lamp and the timer, because I had to take the time and I had to see the lamp was for how it was creating for the sun, trying to melt it. And it was take pictures and write down the time when candies melt.
All right. So you decided to melt them under a lamp, right?
Yes, I did, because that's what came to mind, because how I didn't, if I would melt them with the sun, and how it was this week basically, it was actually really cold sometimes and sometimes hot. So I wasn't going to have time to do that. So I have actually a lamp. So I was like, maybe I should do a lamp instead of the sun. And by the way, if I do it in the sun, sometimes they may fly away or they may get dust. So it's better safer here inside, because like I could watch and take time instead of just going outside and oh my god, I just missed this part because it melted while I was inside.
Yeah.
And I don't like being outside because how there's mosquitoes and all that.
Yeah. Okay. Good. That's a good idea you had. So what were the materials? What kind of things did you need for your experiment?
My materials were actually a paper towel, a scale, a lamp, a phone for the pictures, and for the chocolates I had Hershey's milk chocolate, Reese's peanut butter cups, Nestle Crunch bar, Hershey's cookies and cream.
All right, that sounds delicious. All right, so I see that you have your data table right there. I
actually do.
Uh-huh. And what did you learn from the first time? So you did the experiment how many times?
I did the experiment actually 3 times.
3 times, all right. And the first time you did it, which one melted the fastest?
The fastest, actually I'm going to say Reese's Cup was the fastest to melt. Yeah.
And then what about the second time you did it? Was it the same?
The second time was, yes, also Reese's Cup was also the first one to melt.
Really? And then the third time, what happened?
Also the same. Reese's Cup was the first one.
But the third
Really?
one, yes, it was really melty. It was watery. And the second one, it was like really, it was stable like a little bit, but the chocolate and the peanut butter were like like melting. And then the first one was really, really melted.
All right. And then what came in second place?
Second place, we give it to Crunch Bar.
Oh, really? So you thought the Hershey's was gonna melt. So we
Well,
have Reese's first, and then the Crunch Bar,
the
and
Crunch
then
Bar, Hershey's milk chocolate.
oh, okay. And then so that would be the cookies and cream came in last place.
Yeah, it came in last place.
Oh,
It
okay.
actually did.
All right. And you have what's there under your data table? Those are the
Right here, these are the pictures of the chocolates.
all
How they
right.
are melted.
How they were melted. Okay.
Yes.
And so what was your conclusion there?
My conclusion was basically, when if we set up the candies to melt, then the Hershey's will melt faster. But based on the data and the Reese's, was the candy that always melted the faster.
All right. So the one that always melted the fastest was the Reese's. All right. Very good. If you were to do this experiment again, do you think you would maybe try something different or change something?
Maybe if I would do this experiment again, maybe I might do the same thing, but I want to change the lamp. I want to do it like with 2 lamps and to see which one can take more time to melt. Or also maybe instead of melting, maybe if I have the chocolates melted outside, I could put them in the freezer. I'm like, okay, so let me just start checking and checking. Okay, this one let's say the crunch freeze faster than the Reese's. Let's say that if I would wanted to do it again. But maybe if I would do it again, I would like to do with the 2 lamps to see which one will melt really faster.
Yeah, I like the idea of melting it. It probably will take a long time, but melting it and then putting it in the freezer and see which one's gonna freeze.
Yeah,
That sounds
and then maybe for there, I maybe put a title which maybe chocolate race or freezing race.
yeah.
Or maybe like somewhere around there, freezing race.
Yeah. All right. Was there anything important that you learned?
Well, I did learn some new things because I thought that the Hershey's will melt faster, but no, actually the Reese's did.
I
So
would
that's
think the same thing. Yeah.
Yeah,
Because the
that's what
Reese's
basically
doesn't have anything in it and everything else does.
Yeah, that's what basically I learned about that.
All right. And did you have fun?
A little bit, yeah, getting burned, but that's okay. I also like getting, I loved it. I got to spend time doing this and it was really fun.
All right. So thank you so much for participating. Hey, Crystalline. So
Hi.
we're going to just record a little bit about your experiments. All right. Tell us what grade you're in, what school do you go to?
I'm in 5th grade and I go to the elementary school.
All right. So what is your experiment? What's the title?
Moldy mess.
Yeah. All right. And let's talk a little bit about your purpose. Why did you want to do an experiment on mold? Sounds nasty.
Well, I've been wondering if like bread would mold faster if it had germs or not, or if it was outside or inside.
Oh, okay, interesting. And what was your guess? So when you were thinking about that, what was your hypothesis?
Well, I did believe that the outside with germs would mold faster than the others.
All right. And what were your steps, your procedures that you had to follow?
Okay. My procedure was, well, number one, you had to label bags before putting
the breads inside and doing everything else. Second, you have to put on gloves. Third, take out 4 bread samples. 4, put 2 bread samples in bags with no germs labeled. Make sure bag is sealed. Number 5, rub 2 breads in extremely germy areas, keyboards, hallway rail, and toilet. Number 6, put remaining breads into bags labeled germs. Make sure the bag is sealed. Number 7, remove gloves and wash hands. Number 8, place bags in designated areas with tape.
All right. And why do you think it was important for you to wear gloves for putting the clean one in the bag?
Well, so like because Corona's around, so you won't get like sick or you won't get like an infection or anything. And yeah, so you like won't get sick at all or you won't get any germs.
Okay, so that bread can stay clean too, right?
Yes.
All right. So let's see, we talked about your procedure. Can you tell us a little bit about the pictures in the middle, your data?
Okay. So this here was in November 10th. This is when I first started. I put these 2 breads outside. Nothing happened to them, obviously. And I put these 2 inside. About a month later, I had these 2 results. These 2 breads were from the inside. Nothing has changed from them. But I think there was only a smell from them. Like a smell for them from these and those 2. And from this was from the outside from my balcony. This one on the right, I believe, mold started forming because of the moisture from outside and like water was coming into the bag.
Okay, and is that black dot that I see right there, that's mold?
Yes, this one over here.
Oh, okay.
This one's no germs from the outside.
Oh, okay. And you think what caused that mold?
From the outside, because heat condensation, like the moisture, made the bread moldy.
Oh, okay. So maybe some water got in there.
Yeah.
Yeah. Okay. Did you learn a little bit about mold? What is mold?
So I put a thing here. What is mold? Mold is a type of fungus. These small organisms can be black, white, orange, green, or purple, and live almost anywhere, indoors and outside. Molds thrive on moisture and reproduce through lightweight spores that travel through the air. You're exposed to mold every day. They're usually harmless in small amounts.
Oh, okay. Interesting. I did not know that about mold. I've never studied mold. All right, so let's look at the right side. We have your results, right? And your conclusion. Can you tell us a little bit about those?
The results and conclusion?
Yes.
My results were the bread samples labeled no germs from the inside, germs inside, and germs outside did not develop mold. The bread that was labeled no germs outside developed mold because there was condensation inside the bag.
Oh, okay. And your conclusion was?
My conclusion was, I learned that germs will not affect the bread, but I came to the conclusion that moisture will cause the bread to mold. A completely dry bread will not mold. I also believe that placing them in bags kept them from molding because they were not exposed to the air.
Okay, very good. And if somebody wanted to do this experiment on their own, what would they need to buy?
They would need to buy Miss Bear's bread, 4 pieces, or any other kind of bread. Ziploc bags, depends how many breads you're going to use. Markers to label the bags, and some tape to make sure the Ziploc bags inside the bread are like perfectly still and they won't fly out or move anywhere. And you need gloves so you won't get germs in your hands to get sick. And you need germs so you could test out what will happen to your breads.
All right. Is there anything else you would like to add? I love the orange color and the white border. Is there maybe anything else you want to add, or?
No, not really. Wait,
no?
Like pictures and stuff?
No, just maybe something else that you might have noticed, or something that maybe you would have done differently.
Oh,
again?
Well, I could have switched the bags, like use different like bags like every week.
Oh, okay.
It would like it be exposed to the air while you change the bags like every week.
Mm-hmm. Okay, that would be something to try maybe if you were to do this again. All right. Well, thank you so much for participating.
Hello, my name is Adriano Gonzalez, and the title of my project is Pennies Afloat. The purpose of my project is to determine what shape of clay boat holds the most pennies before sinking. I became interested in this topic when reading a list of potential topics. The procedure I followed included making 3 clay boats of different shapes using the same amount of clay for each boat. Then I placed each boat in a bowl filled halfway with water. Later I placed 1 penny at a time on each boat to determine how many pennies it took to sink each one. These are the results and data I collected while conducting this experiment. The boats floated well without any pennies. Each boat was able to withstand more than 15 pennies before sinking. The circle boat took 24 pennies to sink. The square boat took 17 pennies to sink. The oval boat took 16 pennies to sink. I have concluded that the circle-shaped boat was able to hold more pennies while keeping afloat. There were several variables that could have affected the results. One variable was the placement of the pennies, which could have caused unbalanced pressure on the boat. The other variable was the amount of pressure that I applied on the boat while I was placing the pennies. If I conducted this experiment again, I would change the amount of clay for each boat to determine the validity of the boat shape. In regards to the amount of pennies the shape could hold, each boat would still be equal in the amount of clay used. My experiment could help the development of rescue vessels and could save people in shipwrecks or flood events.
Hi, my name is Jasmine Martinez, and today I will be explaining my science project to you. My science project is about liquids and how fast they evaporate. I will begin by giving you the definition of a liquid. A substance that has a definite volume but no definite shape is classified as a liquid. The particles of a liquid can move by gliding past each other. A liquid can take the shape of its container. Forces hold the liquid particles together so the liquid keeps a definite volume. And now my question is, which liquid will evaporate the fastest? My hypothesis is, I think water will evaporate the fastest because it is the most common liquid. The materials I used is 6 beakers with measuring lines, rubbing alcohol, water, 100% apple juice, nail polish remover, Gatorade, Pepsi's cola soda, paper, and Sharpie for notes. The procedure is pour 100 milliliters of each liquid into its own beaker. Label each beaker correctly with its liquid name. Set the beaker in a dry location at room temperature. Monitor the levels of the liquid for 10 days. Note any differences. In conclusion, my experiment let us know that all liquids evaporate at various rates according to each liquid's properties. Nail polish remover evaporated the fastest, followed by rubbing alcohol, Pepsi Cola, Gatorade, water, and apple juice. Thank you.
Hello, my name is Marco Trevino. The title of my project is Wind Turbines. The purpose of my project is to show how wind turbines work. I'm interested in this project because wind turbines help the environment. With the research done on this project, it is proven that wind turbines are beneficial to our environment. You may be wondering why I chose wind turbine. That is because the wind that is the result of the turbine is both a renewable and sustainable resource.
Hello, my name is Nicolai Vera. The title of my project is Swish, Swash, Which Soap Will Wash. The purpose of my project is to see which laundry soaps remove stains like mustard the best. I was interested in this topic as I saw my mom do laundry and she would get frustrated when stains were still on shirts after they were washed. The procedure I followed was first I cut 3.5 inches by 4 inches pieces in white t-shirts. Then I rubbed mustard on middle of t-shirt piece and repeated on other 3 t-shirt pieces. Next, I let stains sit for 5 to 10 minutes. While I waited for stains to set, I labeled detergent bottles and t-shirt pieces A through D. Then I placed 3/4 cup of A detergent into washer with the A t-shirt piece. I let cycle run and repeated with the other 3 detergents with corresponding t-shirt piece. Last, I let all 4 pieces air dry. I have a chart with the rating I gave each detergent. This ratings are from 0 being the lowest to 5 being the highest. Because none of the detergents completely removed the stain, none was given a rating of 5. LA Stain Lifter almost removed the stain completely, so I rated that one a 4. The other 3 stains were darker and the same, so I rated those a 1. Here are the pictures of the detergents with the mustard stain pieces. With the mustard stain pieces of t-shirts, and here are the actual t-shirt pieces. This is the before and after. In conclusion, my hypothesis was incorrect. Neither Tide nor any other detergents were able to completely take off the mustard stain. Although LA's Totally Awesome Stain Lifter did remove the stain better than any other, practically removing the stain completely. Tide Gain and Extra had a much darker stain after wash. I would definitely try this again using only stain removing detergents. Laundry detergent is used in most households to clean our laundry. Laundry detergent is found in different forms, brands, scents. and of course prices. Unless you've tried many different detergents, one doesn't really know which works the best. My project tested 4 different types of detergents that range from 0.02 cents per ounce to 10 cents per ounce. Unless you're really satisfied with the laundry soap you're using, I challenge you to try the inexpensive ones first because I was very surprised. Thank you.
Hello, my name is Zalako Krias Jr. and my project title is called Vivo's Favorite Food. I love my dog Vivo. I always look forward to feeding him. He gets so excited when I walk up to him with his bowl of food. One day, it got me thinking about what food he likes best. I wonder if dogs even have a favorite food. If so, what is Vivo's food of choice? I decided to do an experiment to find out what my dog likes to eat. Best, knowing Vivo's food of choice will make it much easier to decide what to serve him to eat every day. Question: what food does my dog like best? Hypothesis: my dog will prefer table food over dog food. This is the materials we needed for the experiment. 3 bowls, table food, dry dog food, canned food, and measuring cup. Procedures: gather 3 bowls, place table food, dry food, and canned food in each bowl. Place the 3 bowls on the ground. Observe the food that Viva consumes first. Take notes, record data, redo steps 1 through 6, and record results. Round 1. We put the table food, the dry food, and the canned food. Vivo ran to the table food and sniffed it and ate it all up. Then he went to the canned. He ate it all up too. And on the dry food, he didn't do that much. Round 2. We did the same thing, and it's the same thing. A table food first, and then the canned food second, and the dry food third. Here's the data chart. Alright, types of dog food, table food, dry food, canned food. Amount served, the ounces is 12, 12, 12. Round 1 results, order of food eaten, then table food first, dry food third, and the canned food second. Amount not consumed in ounces, the table food 0, the dry food 1, and the canned food 0. Round 2 results, order of food eaten, and table food first, dry food third, canned food second. And amount not consumed in ounces, table food 0, dry food 2, canned food 0. And I was right. Alright, Vivo's favorite food is the table food, and the second favorite is the canned food, and the least favorite is the dry food. Vivo prefers the table food over the dog food. I learned that Vivo really likes table food. He prefers to eat foods that are moist. And that's the end of my science project.